Okay. Okay. Yes. Okay. So okay. So yesterday it was National Donut Day, I guess. And I'm too fat. And I used to eat donuts a lot. I don't anymore, but there is donuts over there. So yes, have them. And okay. So today we'll start with the necklace. So let's. I gave you guys code for like the blank stuff. Yes. Okay. Yeah. Okay. So we'll start with. I won't write the class right now, like the header file. I'll just write the. So let's do another simple one, which is you have to find if there is a cycle in a linked list. So how do you find if there is a cycle in a linked list? Let's say a linked list is like this. There can be two options that a linked list is straight, and then there is another option that there is a cycle. Okay. So if you make a linked list like I am making, like you would not have a cycle in it. But like let's assume that you have a cycle. So how would you find a cycle? Is that you actually take two pointers, start fast and slow, or like front or back. So fast and slow. So you keep moving fast by 2, slow by 1. If fast reaches null, then that means that there is no cycle. Otherwise, what will happen is that slow will be here and fast will be here. At some point of time, fast will actually catch up with slow. So let's say fast is over here and slow is over here. If you move fast by 2 and slow by 1, which means that the difference between them is getting reduced by 1 every step. So at some point of time, fast will actually catch up with slow. So if fast becomes equal to slow, then that means that there is a cycle, right? So in any question that they ask you for the linked list, you should actually ask them. Yeah, can you give a pen? Thank you. Okay. Okay. So it's a very common question, like a classic question. A lot of people have asked this question.
So on top of this, there used to be one more question that
We will come to those questions. Find the start of the list.
Find the point where both the cycle is becoming so like
Start of the cycle. Yes, I'm coming to that. So, okay. That's the next question. Okay, so I'll write a simple. You guys know how it is. So it's like Boolean a linked list colon is cyclic. Okay. Okay. So what we will do is we will actually take a node a list. We don't need that. If we'll first check if there is just one node or the list is empty. If it is one node, so we'll check if not m head or not m head arrow next. Then return false. I don't know. I mean, like if it is null, maybe you can ask your interviewer, but that's a trivial thing. Okay. Otherwise, we define 2 pointers. So a list node star slow is equal to m head, and a list node star fast is equal to m head. Okay. And then we will go in a loop while while 1. Okay, which means that we are looping forever. I don't like that, but I write it sometimes. So, okay, if not fast or not fast arrow next, bless you, then return is cyclic. No, we don't have
Sorry.
Yes, false. False. Okay. Otherwise, else, if fast is equal to, else if fast is equal to slow, or fast arrow next is equal to slow. In both of these cases, return true. Otherwise, we will do slow is equal to slow arrow next. Fast is equal to fast arrow next. And this code will actually, I have intentionally written bad code, like this code will break in one of the conditions. You can change that.
In the very first condition, it will be returning true. Because fast is equal to slow, so it will not come into the first condition, but it will come into else.
Sure.
So it will break.
Sure. We can, that is one bug. Okay, right. There is another bug that fast arrow next, if that does not exist, in that case it will break, there will be another reference exception.
But we are checking of fast arrow next is whether or not.
It will not break because
We're checking of.
Oh, okay.
No, we
Oh,
have.
sorry.
But it not break.
You're saying second bug is there, that's probably not.
Yes, fast is equal to fast arrow next,
But if
fast next. This might break in one condition, right?
no, it will be null. Fast will come down, right?
We are telling that.
We are checking fast arrow next.
So fast arrow next is not null, right?
Okay.
You
So
already
let's say
checked.
we are over here. Fast was here, right?
Right.
So
Fast next.
fast arrow next, Okay, fast was this one,
Yeah.
right? Fast exists.
Yeah.
Fast arrow next exists.
Yeah.
Both of them exist.
Yeah.
We'll come out.
Yeah.
This does not exist, right? We come out. Fast is equal to, okay, fast becomes null.
So it will
Yeah,
become
yeah,
null,
okay.
right?
Sorry. If there was a condition, I don't know, but anyways, okay. So
What
is, yeah.
Is it possible for the fast pointer to jump over the slow pointer rather than the?
It won't jump, that is the next thing that I'm going to explain. It actually would not jump it. If we were making fast is equal to fast arrow next, which means if we are increasing fast by 3 nodes and slow by 1 node, it might. I'll explain, that's the next question that he was asking. We'll come to that and you'll understand.
What is the purpose of this fast arrow next is equal to slow?
Which one?
But
So,
okay, the next iteration will meet. The next iteration will be because fast moves twice.
yes. It's just to speed up the process. I don't need
So
this.
we are returning true in this case, we are not returning again.
Huh?
In this cases, we are returning true.
Yes,
Was it cyclic?
No, that's correct.
that's correct.
Correct.
right?
Because that's cyclic. If next to next is.
Can we just take an example?
Sure. Okay, slow is here, let's say fast is here, right? I move fast by 2, slow by 1.
Yeah.
So fast comes over here, slow is over here. I move fast by 2, slow by 1. So
That's slow.
fast by 2, so fast comes here,
Yeah.
slow is over here. So fast arrow next is slow, which means that it is a cycle. I did not have to write this,
Because it will
it will eventually meet, but this will actually fast the process.
Reduce one step.
It reduces one step. That's all I'm saying. But it would not. Yeah.
Not only it will reduce one step, but it will also reduce one complete cycle.
Iteration.
Yes.
And second thing, we can also simplify this loop by removing while, because there we are checking two conditions. While one, where we have written, we can remove while one, and this if condition we can remove, and whatever is there
How
in the
will
if
you
How
do
will
loop.
it do it then?
How
So,
will you do?
yeah, so not fast, you can write the if condition, there you
Okay.
can write while. No, just below.
Oh, why?
Yeah.
Over here.
If
Yeah.
will become a while.
Yeah.
Yeah, this condition.
Yeah, you can do that. That's
Yeah.
it's an easy question. I don't think they ask this question a lot, but like this is a very old question.
Yeah.
But yeah, I get all of you understand this, right? So okay. The question that is being asked nowadays is assuming that there is a cycle, right, and you have to find okay, let's say there is a cycle, right? You have to find where does the cycle start, right? That is what you have to find. Okay, so let's say this is the linguist. So the explanation, I'll explain this. The code is very simple. The explaining part is the difficult part. So let's say there are k elements over here, right? So from start to the starting of this loop, there are k elements. And let's say the number of elements inside a cycle is loop size of loop. Okay. So slow starts here and fast starts here, right? Slow is moving by 1, fast is moving by 2, right? So which means that when slow reaches over here, slow has gone k steps, fast would have gone 2k steps, which means that fast would be somewhere around here, and this would be k and fast would be here. Okay? Yes?
Yes. Yes.
Okay. So this side is k, this entire thing is loop. So this part would be loop minus k. Yes? Yes, sir? So this is loop minus k. Now what will happen is, if you think about it, now slow is moving 1, fast is moving 2, right? So if slow is over there and I'm over here, slow moves by 1 and I move by 2, which means what happens is that every step I am reducing the difference between us by 1, right? So slow moves 1, I am moving twice, so which means the difference between us is getting reduced by k. So what will happen is, for fast to catch up to slow, there will be loop minus k steps, because this is the number of steps I have to go to catch up to slow, right? So which means they will meet somewhere. They will meet somewhere around here, right? So fast will be here and slow will be here after loop minus k steps, right? Slow was here, it takes loop minus k steps. So this is loop minus k, right? So after loop minus k steps, both of them will meet. Yes? This is loop minus k, this entire thing is loop. So this part should be k. Yes? 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 So this part should be k. So the distance from here to here is k, distance from here to here is k. So what we do is, now when both of them meet, we will move either the slow or the fast back to this place. So let's say we move fast here. Now what we will do is, we'll keep moving them one at a time, this will travel k steps, this will travel k steps, and both of them, wherever they meet, that is the starting point. Yes, it took me actually a little bit time to understand this. So, if you don't understand, let me know, I can explain this again. Should I explain again? Yes? No? Yes? I don't know, like, should I explain again? Yes, no, I don't know, tell me.
Everybody understands.
Everybody understands? They're pretty smart?
Yeah.
It took me like a long time, it took me an hour to understand this thing. So okay. So the thing is, like, this is k. When slow reaches over here, fast will be here, fast will be at 2k. So this distance is loop minus k. So for fast to catch up to slow, it will take loop minus k steps. By the time s will be at loop minus k. So if this is loop minus k, this is k. So from fast, from here to here is k, from here to here is k. So you move either fast or slow over here and you start moving one at a time, you will meet at the starting point. Okay, I will write the code. The code is very simple, it's not difficult. So okay. Okay. What am I doing? I'm returning the integer. So integer a linked list, find cycle start. Okay. We will check if not m head or not m head arrow next, which means that there is no cycle. So what we will do is we will throw an exception. Throw a new exception like list does not have cycle. Whatever. Right? Okay. We'll take two nodes, a list node slow. I'll just write s. Slow is equal to m head. This node star fast is equal to m head. Okay. M head arrow next. Sorry. M head arrow next. Okay. Yes.
If you are doing m head arrow x, m arrow next, then it will take more iteration.
Okay.
We can't make it m head because then we are saying that both the pointers are not starting from start header.
Okay.
One is starting from start and second is starting from one node after that.
Okay.
So
I'm not getting it. So
like the way you explained earlier,
Yes.
that both slow and start is starting from head, and then the fast is moving two steps and slow
Oh,
is
okay,
moving one.
okay, yeah.
But here we are
Well,
making the
Sure.
logic.
Sure. You can take m head. Okay. And while m head, like I'm thinking, I actually did not, I wrote this code in morning, but there might be a case in which there is actually nothing before the head. So there might be a case when there is just a cycle. So in that case, I don't know how this will work. In that case,
boundary condition.
that's the boundary condition. So I haven't code, like the code that I wrote this morning does not have that. So anyways, okay. So while one, but in the interview you actually don't have to write the exact. Even if you thought about it and you wrote something. When I take an interview, like if somebody comes to me, like I don't, like, yeah, so somebody comes to me and scribbles some code, shows some data structures, I'm happy with it. I'm like, okay, fine.
Logic.
I hope you
The
take
logic.
my interview.
Yes. Huh?
I hope you take my interview.
So that will work if it's absolutely circular.
Which one?
This m head fast and slow will work, and your k will come out to be 0.
How? There is actually a bug. I actually did not. The reason why I actually did not test this one is because like the way I am making a linked list, there will never be a cycle. So I just wrote the code. I haven't tested it out, but I know that there is a bug in this, and you guys can help me figure out the bug and like write. I'll send you the project file, so you guys look at the project file and let me know. Okay. Anyways, if not fast or fast arrow next, I'll throw an exception saying that is not a cycle. Otherwise, if fast is equal to slow, I break. Okay, because both of them have met. Okay, else slow is equal to slow arrow next, fast is equal to fast arrow next. Okay, so we come out of this while loop. At this point, both of them are pointing at the same position. Then what we will do is we'll say slow is equal to m head. So like slow, we move it to the right, and that's it. And while slow is not equal to fast, what we will do is we will do slow. You guys can tell me what to do. Is equal to slow, bless you, arrow next, fast is equal to next, fast arrow next, and when this comes out, we will just return slow or fast, whatever, fast arrow data. Okay? Yes? Everybody understands this? Yes?
There are two ways.
Yes. Okay.
One is this, while I was filling this, we will put not fast and fast arrow next to the while condition, because I was trying to understand this problem yesterday, and
Okay.
it took me almost 2-3 hours, and the logic that you explained made me understand very nicely.
Okay.
Now over here.
Yes, I know there is a bug. So you guys fix the bug and send it to me. I will send the solve
Correct,
code as well as the stub. So if you don't want to look at the solve solution, you can just go to the stub and start coding it. If you want to look at the solution and modify it, I know there is bug in there, and I have not tested it. And there is boundary condition 1, boundary condition is that. And if you guys can send me a written thing, I will actually put it on the website. Okay? Yes? Yes? I want to move fast because
Yeah.
there's too many questions that I want to cover. And we want to do the skip list also. So I haven't coded the skip list yet, but I will code it tonight. I'll see. Yes. Do they use skip list? I have never used skip list since college.
I think like people will tend to use, I think, because I think it's at the same time as binary.
And log and like yeah.
Yeah, so probably it's probably not very much.
But if the linked list is really huge, then yes, it will. I have never used it. I use linked list, but I don't use skip list. And I don't think standard template library also has skip list. I don't think so.
Which library?
STL, template library.
No.
It does not have. Yeah. Okay. Anyways, so we did cyclic start of the cycle. Now we will do reversing of a linked list. Okay. Reversing of a linked list. And there are many solutions. I'm giving you one solution. There is a recursive solution also. Probably I haven't solved that recursive one, but maybe tomorrow we will do that. So okay, we'll do the iterative solution. Okay. So what we do is basically, let's say so this is basically pointer manipulation. So in this, what we do is we take 3 pointers, back, front, and middle. Okay. So we'll point back to null. Okay, middle to the head, then we'll go in a while loop. First you will check with your interviewer that is there a cycle or not. If there is a cycle, you'll probably break this cycle where you'll first find where this starting node is, then you will break this cycle, and then you will reverse this part. I don't know how you do it, but ask the interviewer. That becomes a longer than 1 hour interview. But there is no cycle, so middle front this, right? So now what we do is we will make the middle arrow next instead of, we'll go in a while loop, and we'll make middle arrow next instead of going to front, we'll move it to back. Okay? And then since we have broken this, but we still have the front, right? So what we will do is we will make middle is equal to front, front is equal to front arrow next, and then back is equal to middle. So back comes over here. Okay.
Then we lost the reference.
We will actually not lose it. Let me see.
We need to do middle dot next equals to back and then move the back.
Yeah. So that's what I said. So back was here, right?
Right, yes. So now we move it to
Okay, sorry, I didn't move. Okay, let's do it. So back was pointing to null. Middle was pointing over here. Front was pointing over here. So first what we do is we make middle point to back. Okay. So this is broken. Now what we do is we make back is equal to middle. So back becomes here. And then we make middle is equal to front, and we make front is equal to front arrow next. So front comes over here. We take 3 pointers, so we always have a front. So we'll continue to do this,
Yeah, middle again.
and all these arrows will go in the back, and front will actually reach the null. When front reaches the null, at that point middle will be here. Then we will actually say make the head is equal to this, and we have reversed this. Yes. So that is the solution that I have, which is the O of 1, O of 1 for space, and O of n for because we have to do that. Okay. Okay. Yes. Did you understand that?
Yes.
Yes.
For me, can you?
I'll do it again.
Yeah.
Yeah, I'll do it again. Okay. So this is the linked list. We will have back
Okay.
pointing to null. Okay. We'll have middle pointing to the head, and front pointing to
Head
front.
first.
Yeah. So let's put numbers 1, 2, 3, 4, 5, 6, 7. Right. Now what we will do is we will first point middle is equal to back. So middle starts pointing to middle arrow next. Instead of pointing over here, you break this and point it to back. Right?
Okay.
Middle is over here. We will make back is equal to middle. So back comes over here. Middle is equal to front. So middle comes over here. And front is equal to front arrow next. Next one.
Okay.
Yes. Now we will go again. We will check if front is null. Front is not null. So what we will do, we'll do again. This was pointing over here. We'll break this. We'll point it to back. And then we'll make back is equal to middle. Middle is equal to front. And front is equal to front arrow next. Right? So we are breaking one loop, but we actually have another one front, so we can go
Yeah.
back. So similarly, we keep moving
Yeah.
this.
Got.
So every time it will break the link, and at one point front will come over here. Whenever the front comes over here, we'll break, and middle would be here, and we'll make the head is equal to middle.
Okay.
Yes. Okay. Okay. सारा lowercase है. Okay. So I will write the, where is the pen? Okay. Huh? Okay. So I will write the code for reverse. So void a linked list colon reverse. If there is list is null or there is just one thing, we don't care, so we'll check if not m head or not m head arrow next return. Okay, otherwise we take 3 pointers. A list node star back is equal to null. A list node star front middle is equal to m head, and A list node star front is equal to m head arrow next. Okay, and we will write while one. We will do mid arrow next is equal to back, and then we will check if not front, which means the front has reached null, then we just break. Okay, otherwise we will make back is equal to middle, middle is equal to front, and front is equal to front arrow next. Okay, so this will continue, and if there is no cycle in the loop, this will break out, and at that point we will say m head is equal to middle. Yes. If you need internet password, this is the password. And it is home-8 something, and everything is capital. Okay. Okay, so we did the reversing of a linked list. Now let's figure out, we want to do a palindrome. We want to figure out if a linked list is palindrome. Okay. So, 1, 2, 3, 4, 3, 2, 1. Right? So palindrome is, if you read it from the front and the back, everything is same. So which means that there is a palindrome. Now the problem with a linked list is that I actually cannot read like the last node. If it was an array, I could have just gone to the last node and the front node, compared these two, and then compared these two, and then compared these two, and gone to 4. It will be fine. Now you guys tell me what can be the solution. Like how can you find that? Just give some ideas.
Factorization or recursion?
Anything is
Anything is fine. Anything is fine. My brain mostly does not work recursively, so I have written an iterative solution. If you want to give a recursive solution, that's really good. So,
Reach to the middle of the node.
yes, you know we've done that.
I missed this one.
Yes, okay. So one can be that put everything in a stack, right?
Yeah.
So put everything in a stack. So there'll be a stack. So we'll put 1, 2, 3, 4, 3, 2, 1, and then we'll keep popping the stack and comparing that is the easy solution, but it has a space complexity because you need extra space. Another thing would be that basically you find the middle of a linked list. So you find the middle of the linked list. Say we find this one, and then we break this linked list, and this points to null, and we have another one over here, right? And then we reverse this linked list.
Plus, to get in the middle of the, we have to know the total number of nodes.
You can, in one pass, you can actually get, or maybe I should have written the program for getting the middle of the link first. But
Fast and slow.
fast and slow, right? So fast and slow. Fast will move 2, slow will move 1. When it reaches in the middle, fast will become null, so you know that you are in the middle, right?
So how far the fast should be?
2 at a time.
2 at a time. Fast will move 2, slow will move 1, right?
So if you have like 100 nodes and you are going fast, so your flow will be like 98.
No.
No.
Slow will be 50.
Sorry, so it will be okay.
Sure. So what will happen is you find the middle, you break the middle, and you have pointers to
So
this.
why do correct? If there are even number then?
We will figure out. We will solve that. We'll solve that. While doing the question, we'll solve that. Don't worry. Don't worry. Okay. So this is there. We break it. Now let's say fast pointer was or slow pointer was here. We make slow over here, right? And then we reverse this linked list. So we reverse this linked list. So this becomes 1, 2, 3, right? And then we actually start comparing one by one. So we compare this by this, this by this, this by this. If there is only one left and this is null, then that means that yes. So we'll take care of the odd condition in this, and the even condition will be there. You guys understood this? Yes or no? I can explain again. Maybe I should draw a little bit better. 1, 2, 3, 4. Let's see. Let's say 3, 2, 1. No. Okay.
This is still a palindrome.
Huh?
This is still a
This is still a palindrome. So what? I'm just explaining it again, and then I'll start writing code. So we'll have a slow and a fast pointer. So at the middle, when fast will reach over there, slow will be here, and then what we will do is we will break this and we point this to null. Right? So now we have 1, 2, 3 and 3, 2, 1. So we will take 3, 2, 1 null, and then we will reverse this linked list. So when reversing it, it becomes 1, 2, 3. So now we have 2 nodes, and then we start comparing. So we'll compare these two, we'll compare these two, we'll compare these two. Yes, this is a palindrome. But the thing is, like, now your linked list is broken. So you have to reverse it back. So now reverse this back, so this becomes 3, 2, 1. And when this was pointing to null, instead of pointing to null, start pointing over here.
Why do we even need to break this? We have mid position, go to mid dot next and start iterating from mid dot next.
You can do that.
You don't need
Yes, you can do that. Like, I wrote it that way. So you can do anything. But the thing is, like, if you wrote this much, if you explained this much, I think it's pretty much obvious that you know how to do it. And then in the interview will be, he'll ask you nitty gritty, okay, now why do you need to break, like you're asking me. So, okay. Boolean. A linked list. And if you don't understand, let me know. Is palindrome. If you don't understand anything, let me know. Okay. Boolean boolean b palindrome is equal to true. We will check if not m head or not m head. So next, yes. Oh, Vimal, you are understanding?
Yes.
You know? Okay. Return. You don't. Anybody doesn't understand it. So we'll take a link list star back is equal to m head, and in this one I will actually not use m head arrow next arrow next. I will do it in a different way, so there is no confusion. So a linked list star front is equal to m head. Both of them are m head right now. We'll check while.
Node, right?
Huh? What? Oh, sorry. Yes, a list node. Okay. We will take boolean switch is equal to true or false, whatever. Okay. You'll see why I'm using this. I'll say while front exists, if switch exists, then we will move front is equal to front arrow next, and switch is equal to false. Else we will move front is equal to front arrow next, back is equal to back arrow next, and switch is equal to true. Okay? So in this way, in one iteration only front will move, in the second iteration both front and back will move. When front reaches the end, we will break out. So once we break out, then we will actually break the linked list now. Okay, so have you guys written this, or I'll actually send the code, so if can I remove this and
Sure.
yeah, okay.
Also, we are recording, so if you want, you can go back to recording.
Yes, you can go back to recording also, and I'll send you the code also. So it's not. Okay, and then we will have a list node star temp is equal to back arrow next. So at this point, back is at the middle. So I will take the middle arrow next and I'll store it in a temp variable. Okay. And then I will say back arrow next is equal to null. So I have broken the loop at the middle. Okay. Then I will say temp is equal to reverse of temp. So I wrote a function which will the earlier reverse function was a void, but this function actually returns a node. So it returns the head node. So I reversed the temp and I stored it in temp. Okay. Next, what I will do is a list node star temp 1 is equal to temp. I have taken this one to actually store the value where I have to reverse again. So yes, okay. Then what I will do is front is equal to m head. So the list was like this. Front went out of scope. Back was somewhere here. So then I'll make the front is equal to now I have temp, which is the broken one, right? And then I need to go back to the front. So front is equal to m head while front exists.
What's the
third last line. Just about that.
Yes, this one. I actually don't know why I took this. Like, I think I took this because there was, let's see, this, right? So this was the list. So I broke it off at here. So I broke it. This becomes now, right? So now, then I reversed this list. So this became like 4, 3, 2, 1. So this became 1, 2, 3, 4, something. I think I have taken one extra variable. I can do
No,
without.
so I just wanted to know that is a different one, right?
Yeah. So then I actually stored this
That,
this one.
that's fine.
Yeah. I think like there's one extra variable over here. I should not have taken that. But that's okay. Okay. So while front exists, if front arrow data is not equal to temp arrow data, right? Then B palindrome is equal to false and break, right? Otherwise, we will do front is equal to front arrow next and back is equal to back arrow next. Okay? No, temp is equal to, sorry. Temp is equal to temp arrow next. Okay, so this will continue. If it is not a palindrome, it will break out. Right? And after that, we will say temp is equal to reverse of temp 1. I think I know why I took it. I need to reverse this list to get that back. So I make temp is equal to this, and then what I do is while front arrow next, while front arrow next is not equal to null, then what I do is front is equal to front arrow next. If it was a palindrome, front will actually reach at the end. If it is not a palindrome, then I have to increase the front so that I reach till the end. And now I have to join both of them. So then I will say front arrow next is equal to 10 and return the palindrome. I think I could have done without the variable temp. I could have used back also, but this is the code that I wrote. I'll send it to you. You can give me the optimized solution.
If we have the odd number of nodes, so this will break in this if condition, I guess.
Sure.
So
It
while
might, I have to figure out, there is an indexing problem. I have to figure that part out, that when back reaches, if it is even or if it is odd, then like which one will have the bigger number of
so just one change is required. Instead
Yes.
of while front, if we make
While temp.
it will go.
while temp.
So we are assuming that temp will always be a smaller number because when
So
we divide-
whatever is a small, either they will be equal or one will be bigger. We have to figure out which one is bigger. If the temp is,
But if we are comparing it with smaller, and what about like last?
if the last is there, in case of odd, the one which is remaining, that is a palindrome, no matter what it is, right? Yes?
Yes.
Okay. So I have purposely like not written the right code so that at least you go and try it out. I can explain everything and I can give you the perfect solution. In the interview, you don't have to write a perfect
But at least we should make our doubt clear, otherwise
Yes.
we'll make mistake there.
Yes, I know. Over here, make your doubt clear.
Yeah.
If you do not write this code, I guarantee you that when you go over there, you will make a mistake. So, go ahead, write this code. I have the solution. I'll give you both, like the stub and the normal code, and we'll do that. We'll take a 5-minute break and then we'll start back again. Okay. switch this, I think like he can't see it.
Switch the chair.
No, just not the chair. Just let me see. Okay. Yes.
I can come.
You can, actually you can make the camera here, right?
No, it
Uh,
will not capture the full thing.
I don't know. And the battery on this thing
I can
also.
switch it.
Oh.
Can you come?
Yep.
Oh.
That's better.
Yeah. Okay. Anyways, so we'll take a break. There is coffee and there is donuts, which I should not be eating, but eat. We will, yes. You can come out. You can come out there.
You know which one to do? आपको पता है क्या अच्छा है इसमें?
This one is good, I don't know about it. सब में fat है. Everything, nothing is good. But it's still tasty. Nothing is good.
This is for Sumit, not for me. Then.
Become more fat.
Class का भी वो कैसे ना एक्सप्रेशन चार लोग हैं.
देखो he was जो भी mistakes हैं वो ऐसे ही का हो रहा है I'm बता नहीं खा के देखो एक्सपेरिमेंट आपके सामने अच्छा है This will be yeah, very good.
Okay, yeah, we got it. For example, it's more of like get bored and move ahead and really want to stay at my age. I don't like. I actually don't know.
Because she told us she was not in Excel and she had not been doing it. This is her
Okay. Okay. Okay.
Oh.